In this section, we're going to talk about how to graph linear inequalities. So we're talking about graphing something like y is less than or equal to 3x plus 2, or maybe we're looking at something like y is greater than 4/3 x minus 1. Okay, you always got to start with slope-intercept form. So that would be your first step, is to rewrite in slope-intercept form. So if we had something like 2x minus 3y is less than or equal to 8, then we would have to move that 2x over, divide everything by that -3 to get y by itself. Then we can identify the slope and the y-intercept. So once we have it in slope-intercept form, that's your next step, is to identify the slope and the y-intercept. And you're going to graph the equation, the slope, using the slope and their y-intercept. Just like we did a few sections ago. We're going to use that y-intercept. That's going to be 1 point on the graph. And then we're going to use the slope to find a second point. Now we have to be careful how we connect dots. So if we have a greater than or a less than, we're going to use a dotted line to connect the dots. If we have the greater than or equal to or less than or equal to, we're going to use a solid line to connect the dots. So now, up to this point, we've got the equation in slope-intercept form. We can identify the slope and the y-intercept. We can plot our 2 points. And then we've connected the dots. Now we got to think about shading. That's step 5. So if it's a greater than or equal to, we're going to shade above the line. If it's less than or equal to, we're going to shade below the line. And we could always, if we're not sure, then you're going to pick a point in one area, one region. If you get a true statement, I'm going to abbreviate statement, STMT, then you're going to shade that region. If you get a false statement, you're going to shade the other region. And I will walk you through both of those examples, both of those ways to figure that out. So let's look at a few examples. We want to graph the inequality y is less than 2x plus 1. So I'm going to write that down here. Y is less than 2x plus 1. So here's what we know. We know the slope is 2, and the y-intercept is 1. We also know we're going to have a dotted line because it's less than, and we're going to end up shading below. So our y-intercept is 1. So there's my y-intercept. And then my slope is 2, which is really 2 over 1. So that's my rise over my run. So I'm going to rise 2 and run to the right 1. So there's my point. And if I wanted to keep making points, I could just do the same thing. Rise 2, run 1. So when I graph this, I'm going to graph using a dotted line. So here's my line that goes through there. Now, I said we're going to shade below. So that means this region down here is what would be shaded. And what that means is every point that is in this region satisfies that inequality. Well, let's pretend we're not sure. So we're going to pick a point. I'm going to pick the point 0, 0. Now, based on my picture, it looks like 0, 0 is in that shaded right there, right? But let's pretend we didn't know that. I'm going to plug 0, 0 into my inequality, and I'm asking, is that true or false? So 0 is less than 2 times 0 plus 1. Well, 2 times 0 is 0, and 0 plus 1 is 1. So I get 0 is less than 1, which is true. That means I'm going to shade the region where 0, 0 is. Well, 0, 0 is here, so that whole area ends up being shaded. So far, so good. So now, what if we would have picked something like up here? So what if we picked the point 0.06? Okay, and I'm going to always try to pick something that's easy to plug in. Zeros are really easy to plug in. So if I can pick something on an x-axis or a y-axis or the origin, that's going to be easiest. I don't have to. I could pick some random point over here. I'm going to get the same outcome here in quadrant 3 that I would like at the point -8, 7 that I would on the x-axis at 0, 6. Okay, because it lies in the same region. All right, but what if we pick the point 0, 6? Okay, now we know it's not shaded. So look at what's going to happen with the inequality. Plug in what we know, y is 6. If I plug it into the equation, it says 6 is less than 2 times 0 plus 1. Well, 2 times 0 plus 1 is just 1. I get 6 is less than 1, but this is not true. And since it's not true, it does not satisfy that inequality, which means it cannot be a solution. So it's not a solution. And since it's not a solution, then that's not the region. So we don't shade that region. We would shade the other region. So instead of shading up here where 0, 6 is, we would shade down below. Okay, so that's how the point picking works. Let's look at the next example. We want to graph the inequality y is greater than or equal to -x plus 3. We're going to start by identifying slope and y-intercept. So my slope is -1. My y-intercept is 3. So here's my y-intercept of 3. -1 is the same thing as -1 over 1. So I'm going to move down 1, right 1. My inequality is greater than or equal to. So that means we're going to have a solid line. And then we're going to end up shading above. I'm going to connect my dots with a solid line. And I'm going to shade above the line, which would be this area up here. Okay, if you're not sure, you could always pick a point. We could pick the point 0, 0, and we see how 0, 0 would be a false statement. So if you're not sure, pick a point. I'm going to pick 0, 0. When I plug 0, 0 in here, I get 0 is greater than or equal to -0 plus 3, which says 0 is greater than or equal to 3, which is false. So we would not shade that region. Okay, that's why the region with 0, 0 is not shaded down here. We're shading the opposite region, the other region. Okay, this is not necessary unless you don't know where to shade. If you don't know where to shade, pick a point. Okay, let's look at another one. So we want to graph the inequality y is greater than 1/2 x minus 2. And this is where you may want to pause the video, try it, come back and check your answer. So in this equation, my slope is 1/2, my y-intercept is -2. So I'm starting there. Y-intercept's -2. Slope tells me I'm going to move up 1, right 2. Now I got to figure out what kind of line. So I'm strictly greater than, which means that I'm going to have a dotted line. And I'm also going to shade above. So here's my dotted line. And I'm going to shade above, which would be this region in here. Okay, now if you're not sure about shading, again, we're going to pick a point. 0, 0 is in one of the regions, so let's pick 0, 0. When I plug it into this guy, I'm going to get 0 is greater than 1/2 times 0 minus 2. So 0 is greater than -2. That's true. So that's the area I shade. Shade the area that contains the point that I picked. You can see how that gives me the same graph. Okay, sometimes the equations are not solved for y, so we have to do a little work before we can do anything else. So let's look at an example. We have 2x plus 3y is less than 6. So we're going to do some work. I'm going to come over here. 2x plus 3y is less than 6. So I'm going to start by subtracting 2x. So I have 3y is less than -2x plus 6. And I'm going to divide everything by 3. So I got to divide every term. Remember, math is always fair. Since I divided by a positive, I'm going to keep my inequality. So I'll get the equation y is less than -2/3 x plus 2. My slope is -2/3, and my y-intercept is 2. So I get y is less than -2/3 x plus 2. So now we have enough information to graph. So I'm going to copy that information down here where my graph is. So b is 2. The slope is -2/3, so I'm going to move down 2. I'm going to put the negative at the top, to the right 3. Okay, since it's negative, I know it's falling. I know I'm looking at less than, which means a dotted line. Less than means shade below. Dotted line, shade below. So this is where you may want to pause the video, try this one, come back and check your answer. So for this one, we have 4x minus 2y is greater than or equal to 8. To get y by itself, we're going to start by subtracting 4x. So get minus 2y is greater than or equal to minus 4x plus 8. We're dividing everything by -2. Okay, now remember, when we divide or multiply by a negative, we have to flip the inequality. So instead of greater than or equal to, it becomes a less than or equal to. And then we're going to have 2x minus 4. So y is less than or equal to 2x minus 4. So let's write that note. Remember, if you divide or multiply by a negative, you must flip the inequality. So our slope is 2, which we're going to view as 2/1. our y-intercept is -4. We're looking at less than or equal to, which means we're going to have a solid line, and we're going to shade below. So y-intercept is -4, slope is 2, so from -4, I'm moving up to right 1. I'm connecting those with a solid line because of the equal to parts in the inequality. That means any point on that line satisfies that inequality as well as anything below. I'm going to shade everything below the line. So there's my answer. So this is where you may want to pause the video, try one, come back, check your answer. So in this one, we have 3x minus y is less than or equal to 6. We need to solve for y. So I'm going to start by subtracting 3x from both sides. So I'm going to get negative y is less than or equal to negative 3x plus 6. Then we're going to divide everything by -1. When I divide by a negative, I have to flip the inequality, so it becomes greater than or equal to. So we get y is greater than or equal to 3x minus 6. So I'm going to write all that down here beside the graph. So what is your slope in this one? So the slope's going to be 3, which we're going to view as 3 over 1. And the y-intercept is going to be -6. So I'm going to start at -6. And I'm going to move up 3, right 1. Since we have a greater than or equal to, that means we're going to have a solid line. And we're going to shade above. So my solid line is going to look like this. And we're going to shade above that line. So it's going to be this region in here. We've got vertical and horizontal lines. We'll say we want to graph the inequality. X is greater than or equal to 3. So I'm going to start by graphing the line. Okay, this is a vertical line right here. And sometimes that shading can get a little tricky. So we're going to use that pick a point trick. We looked at greater than or equal to because that's the inequality that was given. We know this is a vertical line and it's going to be solid because of that equal to part inside that inequality. So let's pick a point. I'm going to pick 0, 0. It's usually my favorite one to pick. So if I pick 0, 0, and I plug it into the inequality, my x-coordinate 0, I'm asking, is that true? 0 is less than 3, so it's true, which means that's the region we're going to shade. So we're going to shade to the left of that line. So anything in the shaded region actually satisfies that inequality. Oh, I did not get the whole graph. I didn't zoom out enough. There we go. So this is where you may want to pause the video, try it, and check your answer. So the next one, we're looking at the graph of y is greater than -2. So I'm going to copy it down here. Y is greater than -2. We know this is a horizontal line. We have greater than, which means it's going to be dotted. So -2 dotted. It's going to look like this. It's going to be parallel to that x-axis. Now we have to ask, where are we going to shade? Again, we're going to pick a point. I'm going to pick the point 0, 0. So when I plug 0, 0, really I'm just plugging that y-coordinate in here. I get 0 is greater than -2. Is that true or false? That is true. 0 is bigger than a negative number. So that's the region we're going to shade. 0, 0 was here, so I'm shading this above. This one I think is pretty easy to see that you're going to shade above because it's greater than. But that picking a point always works if you're not sure. So that's how we graph inequalities.